Exploring Existing Solutions to Climate Change by Kate. The first solution is renewable energy. Renewable energy is the most widely explored alternative to burning fossil fuels. It focuses on energy sources that aren't limited and don't produce as much CO2, including solar energy from the sun, geothermal energy from heat inside the earth, wind energy, biomass from plants, and hydropower from flowing water. Generating 35% of electricity using wind and solar in the western US would reduce CO2 emissions by 25 to 45%. As you can see, it can greatly help the emissions of greenhouse gases. The chemistry aspect. Biofuels is one specific form of renewable energy that is made from biomass such as sugarcane, compost, maize, farm waste, and only releases small amounts of carbon dioxide. The chemical processes include fat molecules can be transformed via a chemical process called transesterification into biodiesel, and sugar molecules can be converted by a combination of microbial fermentation and chemical processing into alcohols like ethanol and butanol. These products can then be used as fuels in cars and other vehicles adapted for this purpose. Nuclear power is one of the lowest greenhouse gas intensive power sources and one of the safest, and chemists can contribute to fuel production, reactor manufacture, and decommissioning, to waste treatment and cleanup, and to understanding and monitoring of environmental effects. Solution background. In 1839, French physicist Edmond Becquerel discovered the photovoltaic effect that is essential to solar energy. In 1878, William Armstrong first invented hydroelectric power, and in 1970, Jerry Whitfield invented biomass generation, leading to biofuels. Both the government and private industry will work together to encourage use of renewable energy and to make sure that it's extremely accessible to the general public. Barriers include dependency on fossil fuel for cheap fuel and how our cars are designed, a slight cost increase, or an unwillingness to simply change. Solution number 2, carbon-eating fuel. We can create synthetic fuel using carbon dioxide by removing carbon dioxide from the atmosphere and combining it with hydrogen obtained from water, and this would create a liquid fuel. Using hydropower as electricity, this would be a viable alternative fuel, and in order to keep carbon emissions in check, we will eventually have to require negative emissions, which requires taking CO2 out of the atmosphere and storing it elsewhere. This elsewhere is the synthetic fuel. It is practical because the cost of removing carbon dioxide from the atmosphere has been lowered to $100 per ton from a previous $600, and through California's low carbon fuel standard, which puts a tax on fuel with carbon in it, this carbon removing fuel can be competitive on the market as well. And currently keeping global warming to less than 2 degrees Celsius would require negative emissions or removing carbon from the atmosphere, which this fuel does. The chemistry aspect. Carbon dioxide is removed from the atmosphere and combined with hydrogen in order to produce synthetic fuel. This hydrogen is created using the process of electrolysis, where electricity is used to spur a chemical reaction where H2O reacts at the anode to form oxygen and positively charged hydrogen ions, and at the cathode, the hydrogen ions combine with electrons from the external circuit to form hydrogen gas. Removing carbon dioxide, a greenhouse gas, from the atmosphere will help reduce the greenhouse effect. Solution background. Stanford chemical engineer Matteo Cargnello invented a catalyst that allowed for CO2 to be transformed into gasoline and other hydrocarbon fuels within a reasonable time frame in 2022, but the concept was first brought up in 2018. The private industry would have a bigger role in the solution as they have to develop it and make it marketable to consumers, but the government could help by creating fossil fuel unfriendly laws. Barriers would include cost, consumer unwillingness, and large-scale development of this relatively new technology. Solution 3. Eco-friendly cement. A need for better cement. Currently, concrete is used for everything from skyscrapers to roads due to its strength and durability. However, as a result, concrete production makes up 8% of total carbon dioxide emissions. With an increase in population and need for housing, this will only increase. Improving infrastructure helps climate change. Investing in new infrastructure such as better roads to reduce travel times or upgrading transmission lines would greatly help this issue. However, the construction of this infrastructure itself will release greenhouse gases. Eco-friendly cement developed by Novacen will reduce emissions. 0.6 tons of carbon dioxide are removed per 1 ton of concrete made because of its unique composition of magnesium oxide that catches carbon dioxide as it hardens. Chemistry aspect. Green cement reduces carbon emissions through a chemical reaction that captures carbon dioxide molecules in the structure. When mixed with water, then the carbon dioxide and magnesium forms carbonates that strengthens the cement. in comparison to the chemical reaction of forming concrete with calcium carbonate limestone, which releases carbon when it's heated, as you can see in the diagram to the right. Solution background green cement was discovered by Nicholas Vlasopoulos in 2010 from Novusem, a company born in the Imperial College of London. The solution would be implemented by the private industry using this green cement instead of the usual Portland cement to construct buildings. Some barriers are raising funds for initial production and development of this green cement and convincing corporations to actually use this eco-friendly alternative. Thank you for listening to my solutions or exploring existing solutions to climate change, and I hope you have a great day.